It's a calm day in eastern Antarctica, and I want you to listen to this. Absolutely nothing. Absolute silence.
But there are warnings to be heard from this vast wilderness if we're willing to listen. Between Antarctica and Australia flows an ocean unlike any other, the Southern Ocean.
The Southern Ocean is the most beautiful place on the planet, especially that point in time when you've sailed for 10 days and you realise the water goes all the way around to your right and there's no other continent. It makes you feel really insignificant, but in a good way.
As well as a thermostat regulating our planet's current climate, scientists believe the Southern Ocean can be a sentinel, an early warning system of climate tipping points to come. The entire ocean is changing, from the surface to the depths. When seawater freezes, it leaves the salt behind. The resulting brine is super cold, denser, saltier, and sinks to the bottom. That's why it's known as Antarctic bottom water. It drives a global current system called the overturning circulation.
That circulation is really important for climate because it determines how much heat and carbon the ocean can store and also transport from one place to another.
Late in 2009, a team from Woods Hole Oceanographic Institute deployed 5 buoys at different depths to measure the flow and properties of Antarctic bottom water.
There are only a few places in the world ocean where the conditions are right for this to happen.
And this is one of them, an area off the Mertz Glacier in East Antarctica. They attach floats and instruments along a cable that's 4.5 kilometres long.
We use instruments that measure current speeds and direction, temperature and salinity.
And for the first time in the Southern Ocean, they're also deploying these robotic samplers to run up and down the cable and profile the lower 500 metres. This will add much needed detail to an emerging trend where Antarctic bottom water is becoming fresher.
Fresh water is more buoyant than salty water, so the fresher it gets, the more difficult it is for that water to sink, and that can cause a slowdown of the overturning. So we have not seen a slowdown of the overturning in the Antarctic yet, but we do see this trend towards fresher values. Our leading hypothesis at the moment is that the freshening we see is because the glaciers are melting more rapidly now than they used to in response to a warming ocean. But we still have some work to do to prove that definitively.
Suddenly, a natural event showed the buoys are in exactly the right place at the right time. In February this year, 90 kilometres of ice tongue from the Mertz Glacier was snapped off in a chance collision with a giant drifting iceberg.
It's coming loose and it swung around and it's actually clipped the edge of the glacier tongue and crashed into the corner.
So we're starting to see cracks forming here?
Yeah, that's right. We'll be able to get the before, during, and after sequence, a sort of natural experiment to illuminate the processes that are important for the climate system. In this case, the formation of bottom water.
There is no question that climate change is occurring and is impacting on the physical systems. What we don't know is how that's going to translate then into changes in the ecological systems, the fisheries, all of those things that we depend on.
Which brings us here to Hobart, the global hub for Southern Ocean science. At the University of Tasmania, Donna Roberts and her team are searching for signs of ocean acidification.
That's a good one. Look at that.
This is what she's looking for. Tiny planktonic snails called pteropods. With shells the size of sand grains, they float using their foot like a wing and catch plankton in nets made of mucus.
There are millions and billions of tonnes of pteropods in the Southern Ocean, and in some regions, particularly the Ross Sea area, there is more pteropods per cubic metre than krill. What I do is I'll pick up an individual shell, have to use a wet paintbrush.
No, and steady hands.
Oh, yeah.
Should I tell you if I'm about to sneeze?
Yes, you should. These guys are worth hundreds of thousands of dollars to collect. Pteropods have a really, really fragile shell. All shells are made out of calcium carbonate, but not all calcium carbonate is created equal. There's 2 types, and the scientific names are calcite and aragonite.
When CO2 dissolves, it reacts with water to form carbonic acid and carbonate ions, which which decreases the pH. Aragonite is more soluble, so any change in pH will affect the growth of aragonite shells first.
Now, aragonite is actually in the shells of pteropods and in corals. So corals and pteropods are going to be at risk first if the ocean health and the ocean chemistry changes, and it's changing because we're putting carbon dioxide into the water. We weigh the shells individually. Each shell will be about 15 micrograms.
15 millionths of a gram.
Yes. I've probably weighed a couple of 100,000 shells. We're actually comparing shells from 10 years ago to shells from today, and what we find is that the shells of today are 35% smaller and more fragile than they are 10 years ago.
That means the pteropods of the Southern Ocean and the food chains they underpin may be living on borrowed time. Donna can calculate the CO2 levels when they'll basically run out of shell.
The tipping point for pteropods in the Southern Ocean is 450 parts per million, and we're currently at 388, so we're heading there rapidly, and we think from models that we're going to get there in about the winter of 2030.
From the minutiae of tiny snails to the world's most powerful currents, there are clear signs the Southern Ocean is shifting in response to the changing atmosphere.
The real challenge then is to be able to design very efficient programs that can measure rates of change. But we don't have enough time series from enough areas around Antarctica to say here is how the Southern Ocean is changing as a whole.
To achieve that, Andrew Constable is organising a targeted research program called the Southern Ocean Sentinel.
What we're aiming to do with the Southern Ocean Sentinel is to be able to work out what should we measure that will correctly forecast the changes that are going to happen in decades to come. And at the moment, we don't know how to do that.
All this needs big science on an unprecedented scale. Over a vast area, in some of the most hostile conditions on Earth, scientists have to gather enough data to forecast climate change tipping points. And who will listen if they do?
One of the difficulties that I have with the debate at the moment is that it's leading us along the path of reacting to signals of change. Waiting for a signal for change means that we're likely to be too late. So can we come up with some way of signalling future change and therefore be better equipped to adapt to the future rather than waiting?
If you take a bottle of water from the Antarctic and you look at it under a microscope, it's just beautiful, and there would be more things out there than people are not aware of. And I hope that people actually learn what a pteropod is and actually learn to care for it to save the pteropods. Yeah.